Okay, so today I am teaching Adam.
Hey.
And John and Danny. Voltage, current, power, and their sources. So I'm gonna go through some of the sources, right? Seven different types of sources, and then I'm gonna go through a problem to define some power. And that'll be the voltage, current, power part. So what we have here is 7 different branches, 7 different sources, right? And I have organized them. These circles are independent, right? And the squares are dependent, which means that they depend on something else. So, and these don't, right? The independent branches, they don't depend on anything else. And so the pluses and minus in these 3 means they're voltage sources. And the arrows in these 3 mean that they're current sources, right? So this right here, since it's a circle and it's got pluses and minuses, it's an independent voltage source, right? Since this one has an arrow in a circle, it's an independent current source, right? This one right here, it's got pluses, except it's a square. And it's dependent on whatever it has right here, right? So like here, this is how many volts is carried. That's the definition. That's the number related to this branch, right? Since it's a voltage source, it's in volts. This is dependent on this, so it should be volts, right? It's a voltage source.
Yeah.
It should be volts. So this is equal to V. Essentially, is what that's saying. That 2I equals V. So it is dependent. This source is dependent on current. That's why there's an I there. So if the current is 4, right, and the volts in this source is 8. Does that make sense?
You said if the resistance is...
No, if the current is 4 amps, then the voltage of this source is 8.
Because
Because it's multiplied by 2.
There?
4 by 2. 4 times 2.
All right, yeah, I see.
Does that make sense?
Yeah.
So this is a current dependent voltage source. Right? Okay, so this next one, right, it's the same thing. It's got pluses and minus. It's a square. So it's a dependent voltage source, except it's dependent on something else. Voltage. Right? Like if there was like, this is a battery.
Yeah.
Right, I should probably explain that. This right here is battery. This side is the plus side, and this side is the minus side. Those are really simple. They're independent. The number associated with it is right next to it, and it's always in volts. But like let's say that this source is dependent on whatever this is, right? So it'd be a voltage dependent voltage source. It's dependent on the voltage of something else, right? And so since that, if it was, let's say that V is right there, it is 4, the voltage of this source would be 16 times 3.
So basically, you just plug it in for V, or in
Correct.
other case,
Yep.
I.
This is just a little equation that, it defines whatever number associates with this.
Yeah.
So this is a voltage dependent voltage source. Okay, so this one, it's also a square, and it's a current source because of the arrow, and it's dependent on current because of the I. So if this, let's say that I is dependent on whatever this I is, right? then the number that's associated with this branch is 2 times 3 cubed. You just plug it in. So that is, right, that's just what the number that's associated with this current source. So that is a current dependent current source. This one, same thing, except it's not dependent on current, it's dependent on voltage. So it's a voltage dependent current source. Is that all making sense?
Makes sense.
Okay. Okay, so now that we've explained those 7 different branches, we're gonna move on to this problem. And the only equation that we're gonna need is right here. That's gonna be our best friend for this unit. That equation.
All right.
P equals IV. And so this circuit right here is this pretty simple circuit. And we're asked to define the power at these branches. Those two right there, P1 and P2. Right? And so we have an independent current source. Right? Its number right here is a number that right here is a number that you're going to make up. This number, this is a battery, right? An independent voltage source.
Yeah.
And this is a dependent, current dependent voltage source, right? So, and there's current right here from that,
Yeah.
right, being applied over there. And so, I'm going to ask you for a random number that I can define I as.
All right. Right now?
Yep.
68. All right.
That's not very realistic.
How about like 7 or something?
7?
Yeah.
7 amps? Okay. Okay, so now it's safe to, all right, since I is 7 amps, this is I'm gonna do it in blue. This is gonna be 7. That's gonna be 7. And this is gonna be
2 times 7?
correct. What's 2 times 7?
14.
Right. There you go. So now the
But
power.
hang on. Now, would that be negative 14 though? Because it goes in the positive and out the negative, or?
No,
All right.
no. The current is just 2 times whatever.
Oh yeah,
this is.
that's right. It's current. Yep.
Yep. So the equations that we're going to use right here. Okay. I'll just copy down here. So P1 is going to equal its current flowing through it, flowing through that branch, times the voltage of it. We know the voltage. That one's pretty easy. 8.
7 times 8.
Right. Yep. The current flowing through it is 7. But there's one thing that we're not thinking about here. We have to analyze. We have to like conceptually think about this. So this source right here. Remember, I said that this side's positive and this side's negative. Therefore, what's happening? The power, which is going this way, right? The current's going that way.
Yeah.
So the power is being, it's being given, right? It's going, it's producing power. Therefore, it's negative because it's leaving, right? Does that make sense?
Yeah.
So whatever this number is, it's going to be negative,
All right.
right? So P1,
Negative
Yeah.
56.
correct. And that's in watts.
I
Right.
see.
And so now that you've analyzed this one, right? We're gonna analyze this one. So the current flowing through this, this branch is 7, right? You'd find that earlier.
Mhm.
Okay, so the current flowing through this is 7,
Mhm.
right? But what type of source is this?
It would be isn't it a current dependent voltage source?
Right, it's a voltage source.
Yeah.
So this number right here,
Is in volts.
correct.
So
That's our voltage.
right.
Does that make sense?
Yeah.
And the current's going this way, right? So the current's going this way.
Yeah.
Is it going to be positive or negative power up?
Be positive.
Right, because it's
Since
opposite of
last-
this,
yeah,
right?
The other one was negative.
Right, exactly. So it's just going to be our current, which is 7, times our voltage,
Mm-hmm.
right? Which really what this is the V, the V right here of this source is to I,
Yeah.
right?
Yeah.
So then this equation, if you replace V with 2I, your power would be,
Because the current, so 7 times
it would be
14.
2 times I squared.
2 times I squared.
Because there's if you replaced V
Yeah.
with 2I, you'd have 2 and 2 I's.
I see.
Does that make sense?
Yeah.
And so I is 7.
Mm-hmm.
So 49 times 2 is 98. And that is a positive 98, and it's in watts. That make sense?
Yeah.